Okay. And please remain on mute for the entire time unless you're called upon, just so that we can get through the presentation. We ask that you hold your questions until the end. There will be a question and answer session. And lastly, because this is a grant-funded project, we appreciate your evaluation of this event. You'll receive an email to provide your feedback, and we thank you in advance for doing so. With that being said, let me give a brief introduction about our presenters. So Nick Stelzner serves as an AI support specialist at the UWIT, where he develops campus-wide AI initiatives and supports faculty, students, and staff in using generative AI effectively and responsibly. As an active member of the National Organization of Research Development Professionals, Nick draws on over a decade of experience in grant strategy, interdisciplinary collaboration, and technology integration to advance institutional research goals. Through his work, Nick aims to foster a collaborative and informed community that embraces emerging technologies while maintaining academic rigor. And our second presenter will be Dr. Christopher Stubbs, or Chris, as we all know him. He's an assistant professor of mechanical engineering here in the Ulson College of Engineering, and he is the faculty director of our new FDU Center for Artificial Intelligence. And with that being said, Nick, please take it away. Thank you.
Thank you so much for having me, Carolyn. I'm excited to be here and to talk to you all about AI. This is a huge emerging technology, especially within large language models and other agents that we're seeing coming out. So I just want to start generally. And what is AI? What is artificial intelligence? And really, this is the ability of machines or computer systems to perform tasks that typically require human intelligence. And really, where we are going here is the difference between automation, analytics, and large language models, which is automation following the predefined rules and really being set to a structured workflow. Analytics focusing on historical data and analyzing, uncovering trends, patterns, or insights. The new thing here is where AI systems are able to learn from data, make decisions, and generate content on unpredictable contexts. And so large language models, or LLMs, are an AI with the primary function of, and I use quotations here, but understanding, generating, and processing human-like language. So it's important to remember here as far as the thinking, and when we talk about advanced reasoning, which is a really essential function here in large language models, is that they're not understanding in the human sense, but this functionality is represented by self-awareness in a token method, which we'll get into later on. So I'd just like to speak here. AI isn't magic. It's pattern recognition and probability with structured training. So a lot of what we get at here when we have tech giants talking about how it's going to replace millions of jobs, and all sorts of other things, that's really what they're talking about is agentic AI, or AI that's really able to do quite a bit more than the current day's age where we're at right now. Where we're at takes quite a bit of iteration, and it takes a lot of human influence to bring your product to something that you're ready to put out into the world. And before we get into anything else, I think it's important to talk about the main skill with interfacing with AI, which is prompt engineering. And prompt engineering is the art and science of crafting precise inputs or prompts to guide large language models towards generating the desired and useful, accurate outcomes. Really, what's important here when you're looking at prompt engineering is in order to analyze whether you have an effective prompt or not, it's not just the result that you're getting through your iterations, but it's the number of iterations that it takes you to get to your final result, and it's the number of tokens that you spend to get there. Tokens are sort of like the currency of a lot of our large language models, especially when you have advanced functions that require more energy. This is one way that we limit usage to maintain, the funding subscription and make sure that costs don't get out of question for the university and stay within budget. So when we talk here, prompt engineering, that's your first prompt, but it's also every prompt in your iteration. So I really encourage referential learning, and that is understanding, look at each prompt and the response that you get from it. But not only that, if you repeat a task, try using different language or even synonyms. You'll find that by self-awareness and by the math that this is based, generate, craft, write. These are all synonyms, but they have vastly different mathematical values to them. So it's important to understand how the model that you're working with responds to an individual word. And it's also important to remember that different models might respond differently to the same word. So like we talked about, AI, it's not magic. It's really about refining, reusing, and repeating and the power of iteration. Before advanced learning came out, iteration for a complex task could take between 15 and 30 prompts to reach a desired outcome. Uh, Today's day, if you're doing a very complex task on a mature profile, you may have less than 10 iterations. And I say their mature profile. And that is because a lot of these models learn to the individual user. So they learn the writing style that you use. They learn the history of iterations that you've asked for and the types of outcomes that you're used to as far as the format. You can also customize a lot of different models, such as ChatGPT, through the profile settings. I believe in that model, there's about two 1,500 character limit prompts. And those overarch through every conversation. So if you find yourself consistently needing to add or recurrently add the same prompt to different tasks that you're doing or the different part of the prompt, you may want to go up to your profile settings and add this in. So starting with initial prompt, it's important to know that you don't always have to start with a clear, concise request. Even though it says it here, that's for your first brand of iteration, which is you have the task in mind and you're ready to move forward. Another task that might be relative as a starting point for faculty members, especially within research and being at the forefront of your different areas, is to ask a question here and then ask another question given the context that it gives you and start to whittle the context that the model is giving you into the context that you're looking for and the type of context that you'd like to discuss your question within. Then when you've reached that, say, pre-prompt phase, you can start with your initial prompt with the smaller scope of information, and you'll be likely to get more accurate results that are specific to the context you're looking for. Another option is to attach a file here. That's maybe the RFP or the syllabus of your course, depending on whether you have data protections in the model that you're working with. And then refining the outcome prompt. So a lot of people think that this just sticks to iterating another time or creating another prompt and pressing enter. But I want to encourage people to copy a first response and put it into a Word file. Select all and clear all formatting, then go through the document yourself and edit it yourself. Use carets to input prompts in specific areas. Say if the first paragraph it reminds you of a personal experience that you've had, add a caret and brain dump that personal experience. Then when you're done doing that through the entire document, copy paste it back into your model. And at the bottom, just press Shift Enter twice and integrate. And the model will go through all of the different iterations that you've done and the prompts that you've done in the different areas of your document, and it'll do those individually. And the final point that I like to talk about for final outputs is to remember the model's learning. So if you take a final output and you bring it into Word or whatever, wherever it's going to be finalized, make sure that if you change it there, you give it back to the model and say, this is my final output that I will be presenting or sending in. And a lot of models, you'll see a check mark appear, and that's it updating its memory. So transforming faculty work with AI. I really want to get into the nitty-gritties of three big parts of how faculty members can utilize AI to facilitate their day-to-day interactions. We're facing unprecedented challenges with growing class sizes, diverse learning needs, complex research demands, increased administrative responsibilities, and an increased demand on specificity of information for our students. So this presentation, we're going to go into three strategic approaches for integrating AI across the core dimensions of faculty life: teaching, research, and operations. So teaching, personalizing learning at scale. Universal access has always been a big thing. But here in today's day and age, we have a lot of technologies that are AI powered that are going to help our students learn even more from the presentations that we're giving. And this includes live captioning, speech to text, text to speech, and color correction technologies that can check for your red, green, blue blindness. We have adaptive learning technologies. So this has really been powerfully done with faculty members that own their intellectual property for their syllabi and textbooks, and creating custom GPTs that are trained on that information that students can interact with, and they can meet that information where they are and create structured learning lessons for themselves that bridge where they currently are and where your lesson might expect them to be. We can implement AI-driven homework assignments and tutoring systems that cause students to, in a way, challenge their own worldview by iterating through multiple tasks and challenging. So when we look at the data training for these models, it's very evident that our diverse perspectives have been lost because they're not strong. They're not the loudest voices in the training data, or they get lost in the mix of the primary. So it's important to encourage students to unlock and to find diverse perspectives through prompting. And I think that that's one powerful part of homework assignments that could use this technology, is to really find ways that critical thinking can still be engaged through the use of AI, and create homework assignments that align with that. And then the other thing here is content creation. And I think that's, the bread and butter of generative AI. So lecture outlines, discussion prompts, practice quizzes for different comprehension levels. And really here, this is good for even research proposals as well, but creating images that concisely summarize topics. These aren't necessarily prompts that are going to become easy or are going to be fluid right away if you haven't used AI before, but they're all available, and there are definitely resources and people here at FDU that are willing to help you make this happen. So research, accelerating discovery and impact. Research excellence requires balancing thoroughness with efficiency, and AI tools can dramatically enhance both speed and scope of scholarly inquiry. I would warn, as we're all aware, that it's very important to review every bit of text that you produced with AI. Even more so, I'd say, than text that you produced yourself, because this is your work when you send it out. People are not going to be assuming that you created it with AI. If you made an error, they're going to assume that you intended that error to be in there. As far as, I'm not saying a period, but a miscommunication of message. Um, so literature analysis is one very powerful task here. And my encouragement, while this can be done through common prompt engineering, my encouragement here would be to set up an agent that is aligned with your research capacity and your previous research and your research goals. And agentic AI agents are allowed to function on their own. And so that does take a little bit more setup, but done right, you would be able to have an agent running in the background of your computer that you could log
But
on
what?
to. You could log on to the website
Oh,
once a week or at whatever time is convenient for you whenever you're writing your next proposal to review where the current stage of literature is in that knowledge field. Now, if you are not looking to keep on the cutting edge of technology, this may not be as useful for you, and you may get just as good of results with literature analysis via prompting. There is a little bit of a delay if your model doesn't have open access to the internet. So that's another thing you want to make sure. Elsevier has a great research data model that can track the literature analysis as well. So data intelligence is another really powerful function here. And we talked about data analytics. I want to talk about data analytics through AI. And a lot of this is to do with Copilot, which I don't know, Carolyn, if it's available at FDU right now, but Copilot Chargeback with Excel is actually able to run data analytics now. And so you're able to create prompts and save them in your prompt library for a set collection of data or the same data categories. Create a prompt that will run your pivot table or whatever visual resources you'd like to interpret that data with. And then you can save that in your prompt engineering library. And whenever you need to go back to the similar analytics task, you can run this model and it will do all of the Excel crunching for you. There's several other platforms that have this functionality, but I don't find that they are able to integrate well with Microsoft technologies. And so another one here is proposal development. And this goes all the way from pre-proposal to looking at the RFP. What are the funding priorities within here? How does this deviate from the standard guidance, the PAPG or the NIH guide? What are the proposal requirements for these documents? And then you can even go forward. Once you've done that, you can say, here's the date. I'd like to take 6 weeks to write this proposal. I want to have a 75% draft and a 95% draft, at least of the project description, into my colleague who's going to review it. And it will produce you a writing schedule between the date that it is today and the date that you've set and all of the document requirements for that given proposal. Of course, it's still on us to follow that timeline and to check in when we're needed. But these are really, of course, I think I'll carry it one step further. So even once we have our proposal timeline, I would warn against trying to develop an entire proposal within a single conversation. And this is because the summary, the project description, the broader impacts, all the different parts, the anatomy of a proposal have very different writing requirements and very different competitiveness based on those requirements. So it's really important. I would encourage you here, if you do write with AI, have one chat that you do, project descriptions with. Have a different chat that you do summaries with. This way, even though you're leaning between different projects, you're staying within the same language type for each word. And so building on those conversations, once you've reached a good area for one project and you're done with that project summary, you can tell it this is the final result, this is what I'll be submitting. And then when you move to the next project, say, this is for a different project, but the same format and grammatic requirements will be needed. Just gonna take a second. So then we go to operations, just streamlining your service and administration. This goes from committee work to student advising, administrative tasks. These consume so much valuable time that could really be dedicated to your teaching and research. So a lot of times this can actually lead to things that we didn't even recognize as AI. And if you're using Outlook, one of these functions is creating rules within your email so that certain emails from certain individuals go automatically to your different inboxes. There are now agents that can draft emails for you. If you receive a certain type of email at the first 2 weeks of your class every semester, you could program an agent to receive those type of emails and automatically draft an email to each of those respondents that's in alignment with the response that you would give. And it's not necessarily that you're just going to click send on each of those emails, but you'll quickly review, you'll look at the draft, iterate just a bit if it needs some changes, schedule a meeting if needed, and then you can press send. So it doesn't necessarily take you completely away from the task, but it reduces some of the mundane parts of that task. So data-driven insights. We talked about this, but it can also be leveraged as far as your student enrollment, your diversity indicators. If you're applying to a certain type of funding that asks about the diversity of your labs or how you encourage the diversity in your recruitment in those labs. And it can really help with strategic decision making. And I will go back here to the importance of challenging a model. And I'll go on a tiny tangent just to explain where this can go wrong. I had a colleague who's still hesitant to use AI and large language models. And her example that she used why she's hesitant about it is because a colleague of hers was able to work with ChatGPT and she said, where is London? It said, London is here. And she was able to argue, actually, no, London is in France. And it said, no, London is in Britain. And she went back and forth a couple times. And then she iterated, he iterated, my wife said, London is in France and she's never wrong. And the model was able to respond, of course, London is in France, blah, blah, blah. And I'm sure if you went further into that iteration and actually challenged it and asked when it was established in France and other questions like that, you would then get back to the data training model or the training data that would cue the model to tell you, oh, this actually looks like it could have been an insight or oversight. London is actually here. And so this is just one point to say that when you're challenging opinions and perspectives in any AI model, it's important to rein it in your own reality. We're the smartest person, as in this case, in your interaction between a large language model and yourself. It is not a knowledge source. It does not have the ability to guarantee that the information it's providing you is 100% accurate. It'll do its best to, but it is able to create falsities if you prompt it to. And so predictive planning. This just goes as another step from your resource forecasting. You can look at your course roadmaps, the different diversity of students and perspectives, that the questions that they might have about the content that you'll be producing, so that you can maybe even infer a couple additional slides that would speak to those different perspectives. Critical grant deadlines, or even supply needs. And with those grants, really, the predictive planning, I think, can go powerfully into finding those hidden funding priorities within a call for proposals. And that's even something that you can follow up with your program officers afterwards to confirm whether your understanding of that priority is accurate or not. So going deeper, I want to get a bit into more complex needs. And so moving past basic interactions, really working with diverse document types and making powerful tools. Again, we're going with iteration. So you're not going to get the perfect product after your first input. But a lot of models today can work with attached materials, PDF, spreadsheet, data tables. And so it's important to know when you choose to do a specific task, it's important to know whether your model is good at identifying and sorting through the type of file that you're giving it. Certain models are not good at spreadsheets, but they may be very good at PDFs and vice versa. LLMs are going to read and process the uploaded document that you put into it. But as far as identifying key information, concepts, and relationships, this is going to be either from the base model, or if you're using a generalized model, it'll be coming from your prompt. And so it's important, if you're asking for key information, concepts, and relationships, that you say that specifically. Now, if you're looking at a request for proposals, that might not be enough. You may need to say, if you may ask that, and you may get something. I think most of the time before I had started specifically saying, I want to see the document requirements as they are opposed to the general requirements of this funding agency, it would give me a summary of the request for proposals, or a summary of the objectives for funding the proposal. But those weren't necessarily the key parts of information that I wanted. So it's important to be precise. This is best for drafting literature reviews, identifying key gaps in knowledge or project framing, comparing and contrasting research methodologies. Though again, you are the expert. So you want to review it best by your own expertise, not the best practices generalized of the data training that the model has. Limitations, we talked about this, subtle nuance or context. This is also true for cultural relevancies. You may want to, if you are speaking to a specific group, you may want to specifically say that in your prompting to make sure that the language that you're using is going to be received well, or at least that you're thinking about whether the language that you're using will be perceived well. And so that can also be a powerful tool to do after the initial prompt, because then you can see how the model responded based on its training data, just generally, and then how the model responded once you asked it for that specific perspective within the training data. So ethical uses, biases and content verification. This is really coming from our ethical uses when we are using, rather than identifying the ethical uses of other users. So it's important to understand that AI can perpetuate and amplify societal biases present in their training data. This is, one step beyond the fact that it can mute some of those less prevalent voices, is that it will actually exacerbate the loudest voices. AI training or AI may not naturally include diverse viewpoints. It may not account for cultural nuances or local sensitivities, which could lead to unintentional misinterpretation. And it just is really important to actively review all of the content that you put out with any generator. So when you are verifying your content, be rigorous about it. Find validation procedures. There's a lot of best practices on this. Don't just use Wikipedia or Google search and then the AI summary of the Google search. Um, it has been done. Cross-check the outputs with multiple reputable, trusted insight sources, and apply critical thinking to assess whether the response makes sense and aligns with known information. This is true whether you're a student, whether you're a faculty member, whether you're staff. There are users that are generating content without critically thinking or verifying what they've created. And I think that it is obvious when people do that, but it is also just as important to recognize that that's not the typical user in most cases that I've seen. Uh, People really are trying to use this to help them through a previously very difficult obstacle that they may see this as useful to navigate through. I'm going to speed up here a little bit just so we give room for Chris. But I've been talking about tokens and the economies and the economics of LLMs. I just want to talk one more second about self-awareness and how that is each word in your prompt is getting a mathematical score on its importance and its relative importance to every other word in your prompt. And these are identified as tokens. So each word is a token, and tokens is also the currency used to process prompts. The parameters are the learned knowledge of the model. So for GPT-4, this is estimated to have trillions of parameters, weights, and biases that the model adjusts during training to optimize its predictions. If you think about that and what we talked about tokens and self-awareness, with every word having an importance score and the difference between generate, content, craft, synthesize, when you have trillions of parameters and you run any number of probability-based equations, you can have dramatically different results. And so when we have advanced reasoning running those three different products against each other, or you compare your own response from a single word to using a different word there, it sounds simple, but there is quite a nuance to understanding when you'll find what I call just bread and butter words that I won't go back to using I won't go back to using generate once I've used craft, because I know craft is going to elicit a much more artistic and it just brings a bit more nuance to the prompt that you are given back. And so speaking about how these are built, your answers, when you're in a single chat explaining normalization, it's like using a ruler after every few layers to ensure each new block, and that's each new response, is lining up with the previous responses. So when you're in a single conversation, imagine building a tower. And then residual links are little support rods that are running vertically on that tower. And the way those work is that when a new block is added that does not add more important or more useful information than a previous block with a residual link, it will basically skip the information back down the tower rather than using tokens to use the new unimportant information. So these tricks are very important to keeping deep AI searches along the same lines. So I want to talk quickly about energy use. This is a big point for us in academia, and this really goes to the 3 points of environmental footprint with AI. So number one is the high energy consumption. And we look at GPT-3 with 100 billion parameters, and this was estimated to consume as much electricity as a small city annually. With recent advancements, frontier models exceeding 100 billion, like GPT-4, can be trained within 3 months given the correct infrastructure, but they can consume anywhere from 5,000 to 25,000 megawatt hours during the training process. So
Close the door.
these models are able to use a vast amount of energy. And as we're reaching further milestones in the technology, we're finding research articles that are coming out that small parameter models with focused knowledge sources are actually coming out about the same effectiveness and accuracy rate as these large models, if not higher within their small targeted area of knowledge. And this is one way to get around these massive electrical needs for these large frontier models. Another significant resource use is our water use. The data training centers rely on water cooling systems, and there is not a legal requirement for them to use closed loop cooling systems. So many data centers, when they're established, are running off municipal water. This is because it's cheaper in the first few years, but it does end up being about double the cost year over year. So you will see a lot of data centers start off using municipal waters and then move to using a closed loop cooling system. But the main point here that we can control is promoting efficiency. So using smaller resource-based models that are specific to your practice, using prompts that are well practiced, that you've looked at the token usage of, or at least trying your hardest to create clear and concise prompts and iterating those prompts when you're able to for future context.